Let's get started. Welcome to the session on pragmatics of test-driven development to evolve design. We're going to talk about some of the ways we can benefit from test-driven development, and I'll talk a little bit about some of the reasons to do this, and then we'll get into some examples as well along the way. We're going to go through the first 50 minutes, take a 10 minutes break, and then when we come back, we'll finish up the second part after that. So this is a two-part session. So let's talk about test-driven development. Now, one of the problems we have in our industry is we have been writing code for a good about 50, 60, give or take 70 years, and it's a field that is still struggling really hard to mature. And compared to a lot of other human activities, we haven't been doing this for such a long time. However, the technology growth has been just amazing in terms of what's expected out of us. And so our industry is really struggling hard to keep up with the demands of the world compared to the maturity that we are able to face over time. In a lot of ways, I'm going to say that the software field, if you ask what year it is in software field, the right answer is not 2015. The right answer is 1820. And the reason I say that is, if you go back and look at 1820, the medical field was where kind of like software field is today. And back in 1820, when doctors perform surgery, a patient who survives the surgery often was dead within about 2 weeks. And of course, they didn't know why the patients were dying so quickly, but the doctors were really happy they were successful in performing the surgery, because as far as they are concerned, the patient was alive when they left the building. Now, that's kind of like the software, right? It worked on my machine, right? It doesn't matter that it doesn't work in production, but who cares? It worked on my machine, right? And so that's why I'm saying it's like an 1820 situation. But then, of course, a few doctors realized something is going wrong here, and they started really practicing a few other techniques. And one of them was to, start heating things, and all the equipment they were using, all the things they were touching, they were beginning to, boil them and heat them. And suddenly they found out, they didn't know why, but they suddenly found out that patients were not dying as much when they performed surgery compared to these other really good doctors. Well, the good doctors, what they did was they walked around with blood on their coat, literally, and the better the doctor was, the more blood they had on their coat, until a few people came about and said, hey, you guys are the ones killing the patients by carrying germs. And of course, it took up another 50 to 100 years before a lot of practices in the medical world begin to change. And so, in other words, we really are lacking some of these hygienic qualities in our field. And that's why I'm going to make the claim that the year is 1820 in software development, and we got a long ways to go in terms of how we get better at what we do. But hopefully we can work towards getting better. And one of them is to really be able to get an automated feedback loop. Now, let's think about this for a second. What is agile development? Well, to me, agile development is really feedback-driven development. And what that means is we build stuff based on feedback. Let's think about this for a second. Last time you were asked to build a certain project, a product, an application, or even a feature, and you built it, and then you went and showed to your customers, and your customers looked at it, and they were so excited about what you have done, they came and hugged you. Is that true? No, right? Well, they kind of looked at it and said, interesting, but that's not what we really wanted. And you're going to protest and say, but that's what you gave us as a requirement, right? Yeah, but that's not what we meant. Or, well, that's kind of what we said, but that's not what we really wanted. Here are the changes we wanted to. So in other words, we go through a few iterations to get things correct. But here is one of the problems we deal with. Now, when it comes to agile development, we have been doing these sprints or iterative development, but unfortunately, a lot of agile practices have focused on how do we manage projects, and for a large extent have ignored the sustainable engineering practices in agile development. And without sustainable engineering practices, it's incredibly difficult to be agile on projects. So let's take a hypothetical example here. Let's say I'm a project manager and I decide to go through an agile project in sprints. And imagine for a minute, I got my group of customers here who are going to tell me what the requirements are and help me develop this application. Assume for a minute I got wonderful developers who can crank out code really quickly. So I take my first sprint, And my first sprint, I say, hey, we're going to be building, let's say, 5 stories. So I ask my developers to build the 5 stories. They do a fairly good job. They build the 5 stories. And then we meet the customers and say, ta-da, what do you think? And what do the customers say? Oh, these things are good. These things are not good. I want you to make these changes. I want you to fix this. And then while you're at it, here are more stories for you to add. Well, in the next sprint, what do? We tell our developers, go ahead and fix these things and then add these features for me, please. Well, in the next end of that sprint, we go back to the team of customers, and what do they say? Hey, thanks guys, you fixed all of these things. Oh, wait a minute. This one was different last time, wasn't it? Oh, this one worked before, and now it's broken. Sounds familiar? Something that worked before is no longer working, and now they give us a bunch of more features to add along with bugs to fix, and what happens? This story repeats over and over and over. What does this feel like? Well, those of you who have kids or those who have been kids know what this is about. There are some stores where you can go, and there's this really interesting little toy. There's a huge table, and around the table, there is a little wire attached to it, and there's a wooden hammer. I hope you know what I'm talking about, right? And on this table, there are moles that pop up, and you don't have a clue when this mole is going to pop up. And kids love playing this because it's called whack-a-mole, and the kids kind of stand there and get ready, and a one mole pops up over here, and they take a whack at this. And they don't have a clue which other mole is going to pop up next, and the kids really like to take a whack at these mole, and they play. So the kids enjoy playing this whack-a-mole, and those kids grow up to become programmers, and you know what we do? We create whack-a-mole software. Trust me, this is a lot of fun for us programmers because every morning it's exciting to go to work because you want to know what is going to break today, right? In the meantime, the customers are like, is that what we are paying for? And this becomes very frustrating for customers to pay for whack-a-mole software. So we need to have a really good way to get the feedback loop going. Well, that's great, which means we need to really be able to get the feedback loop. What does that mean? We got to do testing. Well, unfortunately, though, we cannot manually test software because if we do manual testing, it becomes enormously painful and very slow. So as a result, what do? We do as much testing as we can, and then we convince ourselves if something doesn't work, the user is after all going to let us know, so that's okay. So we release software until the users kick and scream and complain, and then what do? We go back and fix those, and then that increases cost of development as well. So automation becomes extremely important. But I want to draw 2 words here that can help us to really understand this. But before I even mention the word, I want to first of all say, I love manual testing. I want to make sure I say that. I really love manual testing. Because sometimes people get very angry and say, oh, you can't automate everything. No, for the record, I love manual testing. But I also want to define what I mean by manual testing or the word testing itself. So to me, the word testing is an act of gaining insight into the project. So that is exactly what testing is for me. It's an act of gaining insight into a project. I was writing a piece of code where I've been coding for nearly 2 days without ever even bringing up the web server. And I was in this wonderful rhythm, the glory of automated test runs. So I'm writing code and my tests are passing, I'm writing test, I'm writing code, and this beautiful with the music playing and nothing really is broken. And 2 days into it, I asked myself, does this stuff actually work? Because you kind of lose faith on this, right? Because the automation testing is passing, but how is the application doing? So I took a break from writing the code and I brought up my web server and I visited my website and I logged in. And the minute I logged in, there were 1,000 things I wanted to change already. This is called the observer effect. Observer effect is the minute you observe something, you want to change it. And the minute I looked at my website, I said, oh, maybe I should change the CSS. Maybe I should change the flow. Hey, maybe I shouldn't really ask the user to enter this data. Maybe I shouldn't ask the user to enter the data here. Maybe I should change the workflow. And all these thoughts that go into my mind, these are giving me insight into the application and how to use the application. That is extremely valuable. Having said that, I want to draw a distinction between the word testing and the word verification for a minute. So what is verification? An act of ensuring what worked before still works. And this is something we have to do all the time because software is a non-linear system. You change something here, something goes up in flame over there. Does that ever happen to you? All the time, right? You change something here, and then you're like, darn it, how did that piece of code break over there? And the first thing we say is, I never touched it, right? And then eventually, of course, we start debugging, and we realize there was an overflow from here that corrupted the memory over here, and that's messing up over there. So this happens all the time. And so when things begin to fall apart, when things begin to break, what happens? It becomes extremely frustrating. So we have eroded the trust of our management, our colleagues, our customers, everybody we have eroded, right? Why? Because your organization, your team comes to you and says, we got a bug to fix. Could you please fix this bug? And while you're doing it, please make this change to the software. And you take a few days and fix it. And then when you're done, you say, hey, I'm done. And then they ask you this most dreadful question that nobody likes being asked. They ask you, does it work? And what is the answer usually? I hope. Well, there is actually a technical name for that sentiment. It is actually called JDD, which stands for Jesus-driven development. There's nothing wrong with it, right? Nothing wrong in putting faith in the Lord and say, dear Lord, please make sure my code works today. I've put in a hard day of work into it. But I think we can't just rely upon JDD to get our work done. It's important to get a really good feedback loop. And so how do we really get that feedback loop into our projects? So we want a really good way to verify that what worked yesterday is still working today, and that becomes extremely important. So for that reason, I want verification. But unfortunately, with any non-trivial software, we possibly cannot be running manual verifications to know that everything works because the permutation combination is so much that no human being can keep up with it. One option is to really hire more people at cheap labor, but there's a limit to how much you can actually scale, and eventually humans also are really bad at repeatedly checking for things. We're not as good as machines to do those kinds of work, and we eventually fail at it. So in other words, it is really important to do automated verification. In fact, I would say no human should ever subject themselves to manually verify software. That should be considered an insult if somebody tells you, go run this program and key in these things and tell me this actually works. The other day I was talking to a tester and I asked him, what's your title? He said, I'm a tester. I said, what do you do? He said, they give me a test script, I type those things, and I click this button, I see what it tells me, then I click this button to say the test passed, or click here to say the test failed. I said, what's your title again? He said, I'm a tester. I said, no, your title is called Click Monkey, right? Because that's what you do, is you're just clicking away, no intelligence involved here, and very soon we can train a monkey to do this, and we don't need the human to be doing this, right? So no human should ever subject themselves to really do automated manual verification. It should be left to the machine to verify in this regard. So testing is a very noble task, and this is where human intelligence is very much needed. Hey, is the application intuitive to use? Is the application workflow really good? Is it really taking information that it's supposed to? Is it presenting information that's valuable to the user? How is the performance in this particular area today? And how can we improve by avoiding certain work we do? A lot of these thoughts we have to do. That is testing for me. And we have to do that manually. But verifying that the code actually worked yesterday, does it work today, is not something a human needs to invest time in. We need automation on it. So we can all agree that we have to automate testing, but then comes the problem as to how do we actually automate the testing? Well, I looked at 3 different organizations. So 3 types of organizations are out there in terms of how they adapt to this particular idea. The first type of organization is no automation. These are organizations called organizations in denial. So they are in denial completely, right? Oh, we don't need this stuff. We're just happy doing this manual verification. We don't have to do anything at all. And they are just waiting for somebody to eat their lunch one day and they'll go out of business eventually. This is just a model that is unsustainable. Any non-trivial software, we cannot keep up with this. Now, there are a few problems with this kind of approach. One is that we cannot cost effectively keep up with the software. But there's also a time when cost is not the only thing. I have a client who called me and said, hey, why don't you come and help us with automation of these verification? And my very first question was, how much money are you wasting because of these errors that creep into the software? How much are you really wasting? And they said, every year on one product alone, we are spending $1 million just on this one product, $1 million because of the problems in lack of verification. And I told them, if all you're spending is $1 million every year, don't change a thing. Because for you guys, $1 million is a drop in the bucket. When a company is multi-billion dollars, they don't need to stop and worry about $1 million they're wasting, so don't change it. And they said, oh, you almost convinced us, Venkat. But the real problem why we want to do this is not because we're wasting $1 million, it's because we got lawsuits. And we are in the court of law trying to defend ourselves. And that is something I'm beginning to see more and more today, is companies being sued for creating poor quality software that doesn't work, and that's only going to get worse moving forward. I've personally served as an expert witness on quite a number of projects. I almost serve at least once a year, and they call me and say, take a look at this software and tell us the quality, and it's so easy to see how it sucks. And it's very easy to prove poor quality than to prove good quality after all, so it's very easy to really show for these things. This happens over and over and over, and that is only going to get worse. Well, then there are second type of organization. These organizations say, yes, automation is key, and so they have realized that they have to do automation. But what then they do is they hire these people called automation engineers, as the title is called. We always have fancy titles. So automation engineers, what do? They show up to work one Monday morning and say, hey, I'm the new automation engineer on your project, they announce. And the developers, the programmers are busy coding. They look up and say, hey, welcome to the company. Now leave us alone. Don't bother us. And they go back to coding, right? And what do these automation engineers do? They look around and say, the boss wants me to automate. The programmers don't want to talk to me. What in the world can I do? And they get this fantastic idea. I don't need anybody's help. I can automate at the UI level. Because this seems like a brilliant idea for a minute, right? Because I can write the automation test at the UI level. So they say, I'm going to do automate at the UI level. Now, there is another name for this technique. It's called pathway to hell automation. Because what happens very quickly is, almost every company I talk to, when they have done this, they tell me when we used to do automation. And I ask them, why are you using the past tense? And they say, because we had all this automation working until these damn programmers came together one day and they changed the API completely, and the UI they changed it, and all our tests broke within 5 minutes. And nobody has time to go back and put them together to work again. And so these are like ghost towns left like that, and these tests left to die, and they don't maintain it. And now we don't have any test at all to run anymore because they're extremely brittle. Now there is a name for this as well. You can Google for this. This is called the ice cream cone pattern. Now don't be fooled by the word ice cream cone, because the ice cream cone here is actually an anti-pattern rather than being a pattern. And the ice cream cone pattern says you do a lot of testing at the top level and you do very few tests at the bottom level. And why are we forced towards ice cream cone pattern? Well, the reason is because it's easy for us to write tests from the outside without any cooperation from the rest of the team. And so we take a stab at this to begin with. But unfortunately, this is very short-lived, and almost every company that I've come across has said we don't do this anymore, except one client who told me, oh, this is awesome, we do this, and it works for us. I said, it's not supposed to work. Oh yeah, but we have figured this out, it's working. I said, can you show it to me? And they said, oh, come on over, I'll show it to you. And I go to this person's office. He's running this on this machine. It's doing its job. He said it's only taking about 12 hours to run. It's a little slow, but it works. I said, you know what, this is awesome. If this is working, I need to spread this word around to the world. They all should know to use this technique and the tool. So I'm going to be back in 6 months, and when I come back, I will learn everything about this, and I'll go give conference talks about it. And they said, oh, that's cool, that's really awesome. So 6 months later, I was back in the company. I went to this guy and said, remember last time we spoke and you said I could, get insight into your tool. Can we look at it? He said, oh yeah, but 3 months ago we quit running that. Because one day we changed quite a few things and it broke and it doesn't work. So sorry, we don't have anything to show you, right? So this is the story I see every time, over and over and over. It doesn't work. There is another problem actually. This was actually a client of mine, and they were doing automation testing, and their boss calls me and says, hey, one of my testers has trouble with the automation testing. Could you please help? And I get on Skype and I spend about an hour with this person, and we are looking through the automation test he's writing. He's writing the test through Selenium, and he's automating something very, very simple. All he is doing is, there is a little drop down. He clicks on the drop down, a list shows up. He selects an item on the list, and immediately the drop down collapses, and it immediately updates a little text box with some other data. So very simple. He does this manually, verified. Hey, manual verification, it works. And in a very good, right? They say the pathway to hell is created on good intentions. So he had really good intention. He said, I want to automate this stuff. And he writes a Selenium automation, and the automation says, click on that list box, and then when the list pops up, click on that item, and then verify that the text box has this data. And it doesn't work. We spend an hour. At the end of the hour, I tell him, you know what? This is the reason I tell people not to do this. Don't do this. Go work with your developers and go one level below the UI and write your automation test one level below the UI. I tell him all of this. And of course, the meeting is over. And 6 months later, I travel to his office. And I'm here in Europe. I'm sitting in his office. He comes to me and says, remember back in January we talked about this? I said, of course I remember very well. And I told you not to do it. And he said, well, I've been doing it. I said, this is awesome. And how did it go? He said, it doesn't work. I said, okay, well then quit doing it. No. I actually was waiting for you to come because I'm really hoping you can give me an insight into this. Please, can you do this? I'm not kidding. We spent 3 hours sitting next to each other, and I'm beginning every minute to feel like an idiot because this is not working, and I'm scratching my head. Why would this be so hard to do? And then it dawns on me what's going on. When you click on that button, it has a drop down. You click on the item, that shows up, but there's one problem. I'm a human being looking at this, and human beings have a delay of 200 milliseconds. You don't see an action that happens until 250 milliseconds has taken place. That's why when the fan moves, you don't see the fan blades, right? Because it's revolving at such a high rate, you don't see it. And of course, you see the fan blades when it doesn't move. If you don't, you need to see a doctor. But the point is, at a certain RPM, you don't. And it dawned on me, oh my gosh, there is a human delay involved in this. But when I wrote the test, I did not account for it. So what did my test do? My test said, click on the list box, okay, select that item, and immediately says, do you have the item in the text box? And the code is like, no, I haven't had a time to even respond to your event. And the minute I realized this, I'm like, darn it. And what did I do? A little sleep of 1 second. And guess what? The test worked. And the tester next to me is like, cool. Like, no, this is not cool. Because how much delay are you going to put in here? And you put all of this, and everything seems to work until the developers change something here, and everything comes crashing down again. So this is a pathway to hell. That's why you can never be able to be productive at this. We try really hard, but most of these end up being extremely brittle over time. And I see this pattern, anti-pattern emerge over and over and over in organizations. So what can we do? Again, Google for this. Mike Cohn wrote about this in his book. It's called the test pyramid. And this is the third type of organization that are out there doing automation at the right level to the right degree. So this is basically what they are doing, is they are doing automation to the right level, to the right degree, and this is often called the test pyramid. So the test pyramid, as you can see, is like a pyramid. You do more tests in the bottom levels, and as you go up, you do fewer and fewer tests. But at the very top level, you simply do smoke tests to make sure things are still working and they are still connected together. You don't do one of the reasons is you should never write business logic in the UI. Well, this forces the logic in layers below that you can automate and test it more easily. That becomes a lot more easier and effective to work as well. So in other words, we really want to move towards a test pyramid as much as we can, and we have to really automate. So automation verification is not an option. It's a software crisis right now, in my opinion, that organizations are not doing automated verification in the right level, and we are facing the consequences of that. So we really need to rethink about the way we develop software. We should really start automating and getting verifications. Now, I'm not just saying this because I believe in this. I'll actually say something else that actually changes the way I view the world. There are two problems, I think, in our industry. The first problem is, raise your hand if you build software that you actually use. Not as one person in the room. Well, 2, 3. You're all liars now, right? So most of us don't use software that we actually build, unless you are a banker who's building software for a bank, right? And very few of us actually build software for our own purpose, our own use. Second thing, raise your hand if you pay for the software you are creating personally out of your pocket. Again, very few hands go up, right? And most of us don't. We get paid to develop software. And guess what? This is the best position to ever be in, because they hire you, and what do? You create crap. Now what do? They pay you to clean up the crap you create. Why shouldn't we be in this business, right? This is awesome, because you hire me to do a poor job, and you hire me again to fix it. Why should I complain about this, right? Unless we have a very clear professional and ethical context in this case, there is no reason for us to change the incentive here. This is awesome. We can continue doing this for a very long time. So at some point we have to say, this is morally wrong. We cannot be really costing so much to develop software. Well, I create software for not my use. I'll tell you that for sure. Most of the time I don't use the stuff I create. But I do create software that I pay for personally out of my pocket. I'm here talking to you right now. If my application, which is in production, fails right now, there are only 2 options available. I'm going to spend the night tonight fixing that code. And I guess what? I've got a flight at 6 in the morning, which means I have to really be awake the entire night, fix the application, do JDD, and make sure the code actually works before I take the flight, and spend the flight cursing myself why the application failed and what's going to happen when I'm on the flight with no internet connection. And trust me, that has happened. And I was where was I actually? Well, some part of the world about 2 years ago, and I was about to take the flight in the morning when I get an email saying my server has failed in production. And you can imagine the panic, because it was 8:30 in the night, I've got a 6 a.m. flight, and I spent the entire night cursing myself, putting this back into production, learning a very important lesson about what I did wrong, and fix it. And so if my code doesn't work, I got to pay for it. Or I can hire somebody else and say, would you please take my money and fix the mess I created? In both cases, I'm going to lose. So when I created the software, I created it with enormous amount of automated verification, so I get the feedback very, very quickly. In fact, I remember the day I did this one thing. You can curse people, you can call them by name, they get a little angry with you. But if you want people to get very, very angry with you, mess with their money, right? This is the worst thing you can ever do. Well, I had to write a code that processes credit card payments. Nothing in my life I have done that made me more nervous than writing code to process transactions. Because if you mess up a file, you can restore it. If you delete something, you can get it back. You mess up somebody even $1, they curse you and they drag you to the road, right? So you never mess with people's money. So what did I do? I wrote my test 100% automated, And I remember clearly writing this code on a flight. So I took the entire flight time to write this code. And of course, I was on the flight. I didn't have internet connection, so there's no way I could integrate it. But I had 100% unit test passing and all the integration tests disabled because I was on the flight. And I'm a crazy guy. This is what I am. And as soon as the flight landed, literally, I come out of the gate, find the first chair. And I remember spending 2 hours in the airport making this execution work with the integration test. And that's the way I'm wired. I can't let go of things and walk away. So I'm here in the airport coding away. And once the coding is done, hey, this is integrated. All my integration tests are passing. And now I'm like, oh, this is awesome. My automated unit test is passing. My automated integration test is passing. And I did not, for once, bring up the application and manually key in things. And I said to myself, here is the challenge I'm going to pose. Let's try this. And I deployed the code without ever actually physically testing it manually, right? And I deployed it. And you got to now make sure it's working. So I found the best person who could help me with this. I called my wife. And I said, sweetie, could you do me a favor? Go to this URL and could you please buy this? She said, are you kidding me? You want me to pay for your service? And I said, well, I'll pay you double the amount. She was on it right away. So she went in and she keys in and I said, enter the credit card detail, click. And she said, oh, it went through. I said, yes, it did. I got a little notification here that your request went through. And anything else I can do for you? I said, yes. Could you please key in the wrong credit card number and try it? And she said, that's going to cost you double again. It's like, no problem, right? And so she keys in the wrong credit card, tries it again, says, it got rejected. Yep, I see that it got rejected here too. Thanks for your help. You are my manual tester today, right? But I did that in production. And of course, call me stupid, but I had the confidence this will actually work. And it's been about 5 years since I put it in production. Never had to look back at it, even though we had to change the system so many times. So the point really is, when your money is invested, more than money, when your reputation is invested, you want to think about this very differently. It's much easier to say, I would have done this only if my company wanted me to do it. But at some point, we have to turn around and say, what is our professional ethics in this? We can't obviously be developing poor quality software which doesn't give us feedback. It's extremely important to be able to do that. And that's one of the reasons why this automation is extremely important. So what are the types of tests that I would like to create? The type of test I would like to create are threefold: positive, negative, and exception. So anytime I sit down to write a test, here is what I normally do. I'll give you an example of this. I wanted to implement yet another feature that touches on financials. I always get nervous about this. I wanted to offer coupon for people. So people can come to my site and they can subscribe using a coupon, and they can say, I want a 10% discount, I want a 50% discount, and sometimes I even may offer a 100% discount special for some people. So I said, I want to process the coupons. How do I do it? And I said, I'm going to start writing automated tests, and when I'm done with all the automation tests, when I have no more tests to write, I'm ready to put this into production. So my very first test, create a coupon with a start date and an end date. Immediately, that's a positive test. Immediately my mind says, what if the end date is the same as the start date? Is it possible? Why not? I could offer a very short-term coupon on Twitter and say, this offer ends today, right? Absolutely, I can do that. Or what if the end date is before the start date? Maybe there was a user error keying in a wrong date. Oh, can I give a coupon to somebody? I give him a coupon. He says, oh, this is awesome. I'm going to use this coupon 200 times, right? Well, I got to make sure he never uses a coupon more than once. But he says, what about me? Oh, well, of course, a coupon could be used by multiple users, but never multiple times by the same user. More tests being written. So this is one of the things I really like about this is, I usually keep a little piece of paper. On the paper, I jot down the test I want to write. I don't put this in the computer at this point. I just keep a list of tasks, and every time something comes to my mind, I add it to the list of tasks on the piece of paper and say, next test, next test. And here's what I've noticed. When I write these tests, I would write a few of them, and I would take one of these tests in the list, and I would start coding. But while I am coding, more thoughts would come to my mind. For example, oh, when I offer this coupon, what's going to happen if there are two coupons with exactly the same coupon number? Is that possible? Is that valid? Oh, sure, I can have the same coupon name, but not concurrently at the same time. For example, I want to say New Year sale. I want to have New Year sale every year, but I don't want to have two New Year sale on the same year. Another, oh, this is a condition, more test. And this is one thing I found to be a little bit really weird. Every time I take my eyes off the task list and I look back at the task list, it's as if the task got together and produced more little babies along the way. So this task list keeps growing and growing, and then eventually I start implementing them. And so the sequence usually is more tasks and then fewer tasks remaining, more tasks remaining, fewer tasks, and then eventually they all kind of die out. Oh, there's no more tasks to really implement anymore. I'm done. So you can keep looking at these task lists and you can drive the design and code based on these task lists quite effectively along the way. So when it comes to these, I would think of a positive test. A positive test is to say, does the code do what it's supposed to do? I am meeting all the preconditions. I'm meeting all the requirements. I'm not violating any invariant. Is the code doing what it's supposed to do? I deposit $100. Did my balance go up by $100? That's a positive test. A negative test, I'm going to violate the preconditions. And when I violate the precondition, what does the code really do when I violate the precondition? That is a negative test. For example, I once had a mortgage with the company, with the bank, and of course I had an automated system to pay the, automated setting to pay the mortgage. So every month on the third day of the month, they would take money away from the account automatically. This worked really well because I don't have to waste my time and effort paying this mortgage. It is all automated. Well, I decided to refinance my mortgage. So I took a mortgage from a different company because they had a better interest rate. And of course, the second company that I mortgaged with paid off the first company, so everything is wonderful, right? Well, about 2 months goes by, and I was on one of the trips, and my wife sends me a text saying, "You've been taking some large amount of money from the bank. It's okay with me if you need it, but I just want you to know that we got less fund and you need to really let me know so I can keep the funds available." I said, "What do you mean I'm taking money from the bank? I don't even remember the bank account number anymore. So you manage all the finance, I don't. So if the money is missing, we are in trouble." And she said, "Okay, we are in trouble because I didn't take the money, you didn't take the money. Where is it?" Well, we didn't really know where the money is. I start looking through, we call our bank, and eventually we found out what actually is happening. Well, remember the mortgage we paid off? That company has been still taking money from our account every month, and they forgot to put a little logic in there that said, if you want to pay into a mortgage, the mortgage should still be open. Oops. A developer who wrote the code didn't really implement that logic. So the automated payment said, you know what? You got money coming in. You got money coming in. It doesn't matter the account is open or not. So they've been putting money into a closed account, which really made for a very fun conversation because the person said, "I've never had money go into a closed account. How do we take money from an account that is not even active anymore?" So they had another 10 days to figure this out and before they gave the money back. That's exactly the point of a negative test. Are the preconditions still valid? If the preconditions are not valid, how does your code handle this logic? We need to write tests for it. And then comes along one more, which is called the exception test. So what is an exception test? Well, your code is supposed to throw an exception. Does it throw the exception at the right time and the right exception? You want to write tests to make sure the code is in fact throwing the right exceptions. Now, sometimes you would hear programmers tell you, "Oh, I don't need to write tests for it." Why not? Because that exception will never happen. Well, if the exception will never happen, can we remove the code that is for the exception? No, we can't, because what if it happens? Well, wait a minute, it either doesn't happen or it can happen. It's not both ways. So you must be able to simulate a condition where that exception can happen. But we struggle with this often. And I figured out finally why we have difficulty writing tests for these things. And it's important to understand why we have difficulties, because learning about why it is difficult can help us to cope with it quite well. Have you ever heard somebody say, "This code can't be tested"? Have you heard this statement? Yeah, we have heard that sometimes, right? Actually, what they are telling you is something a little different. They're telling you one or the other, or potentially both of these statements. So when somebody tells you this code cannot be tested, what they're really telling you is the design of this code sucks. That's what they really are telling you, right? Because if a code is poorly designed, you cannot test it so easily. And oftentimes, the sign of having difficulty writing automated tests on a piece of code is a design issue. It becomes really hard to test a piece of code that's poorly designed. For example, a very long method. How do you test a long method? It is like trying to feed vegetables to children, right? It doesn't want, and it's very difficult to force it into it, and it says, no, I don't want you to be writing tests. There's so many permutation combination, you cannot possibly write a test for it. There's another reason for this too, and the second reason is, I have no clue. This is much more difficult for us to accept, because as programmers, at some point we must be willing to say, I don't have a clue how this code is working. I was pairing with a developer the other day, and he had written a piece of code, and he wanted to really write automation testing, and I told him, here's what we're going to do. We'll remove the code, pretend it doesn't exist. We will do this test driven, and write test and write code, and when we are done, we'll integrate this new code into the application, and if it still works, our process worked. He said, that's awesome, let's do it. And as I was going through it, we had to implement a certain feature, so we looked at the old code he had written. I said, what does this code do? And this guy looks at it, and then looks around to make sure nobody is around, and he leans over to me and says, I wrote this code, but I have no clue how it works, so don't ask me again. So the point is, we copy and paste code sometimes, or we are so desperate, we try 20 different things, and finally one thing made it work. You're like, leave it. It's working now. I'm happy it's working, right? So sometimes we don't know how a piece of code works or what makes it work. For example, I wanted to really talk to Amazon Web Service and work with a certain file handling. And I've never, ever done this before. This was the very first day I wanted to do this. And what did I do? Like anybody else, I looked at the tutorials on the web. I looked at all these wonderful examples that show me how to get the information from Amazon and work through it. And 10 minutes later, my code works with no testing at all. And I said to myself, what do I do now? My code is working, but it's not automated verification. I don't have any test on it. I can't put this into production, obviously. So what should I do? Well, I removed that little code example. I started writing the test for it, and I realized that's when I have no clue how this actually works. Yes, the tutorial showed me how to do it, but the tutorial didn't tell me why the code works or what's going on. It took me 4 hours to make this test to work. And you may say, my gosh, 10 minutes you were done. It took you 4 hours to write this automation testing. Is it worth it? And I would tell you, it is 100% worth it. Because that 4 hours was about 4 years ago. And the beauty is, 4 hours over a 4-year period or 5-year period is negligible. And the beauty is, I've made changes to the code so many times, and every time it's given me verification that what worked before is working still, and that's the benefit you get out of it. So at some point, we have to ask ourselves, how do I design the software, and how can I understand what this is actually doing? So when you go to developers and say, write test before you write code, they feel like everybody involved in this conversation is an idiot. Because how do I write code? How do I write test without writing code? Now you may wonder, when you tell programmers to write code, they're able to write code, but why are they not able to write test before they write the code? I think I finally understand the reason for it. And the reason is, does anybody, honestly, you sit down to write code and you just write code and it works. Does that happen to you? If it happens to you, we have divine power in our presence, right? It doesn't happen to anybody. As programmers, maybe a few times things just work. Why? Because you've done this code about 1,000,000 times before you can write this little code. But most of what we do every day. You come to work, you write code, it doesn't work, you scratch your head, you think about this a little bit, you rewrite it, it doesn't still work, you Google for something, you talk to your colleague, you think again, you scratch more head, and then eventually it works. So to me, writing code is a series of mini experimentation. And every little step is an experimentation. You're trying this, you're trying that, you're trying this, you're playing with it, and eventually you make things work. And when what you're doing is something you have never done before, or you're not very fluent about it, then it's very difficult for us to write tests before we write code, because we don't even have a clue how to write code in the first place. So what do we do about it? My recommendation is, first of all, be very honest about this. Be very disciplined about it. When you don't know how to write a piece of code, don't worry about it. Don't write tests for it. Leave your project in place. Move over to a separate directory and do a very quick, active, quick prototyping. So do a very quick prototyping of the code you are trying to implement. This is away from your code base, away from your real project. Do a very rapid prototyping. And the prototyping gives you an insight into what the code is supposed to do and how you would possibly get towards it. It gives you a clue about one solution. And the minute the prototype works, have the absolute discipline never to copy the prototype into production. This is where the problem often comes in, when we turn prototype into production and everything goes to hell after that. So you tell yourselves, no, the prototype stays there, and if you really have trouble with it, delete the prototype. Otherwise you have enough discipline, you say, I won't bring it. Then you start test first, test code, test code, test code, have a nice rhythm. When you do this, and I've done this quite a few times, and every single time, the code I've created after I prototyped and the code I created using test-driven development, that code is never the same shape as the prototype I created. And the prototype I created is crude, clunky, it works, shows me insight. The code I write through test is way more modular, much better structured, better interfaces for the functions, better variable names, and structurally it looks a lot different than the code I created through active prototyping. So what you really want to do is, you want to get insight quickly from prototyping if you're not sure about the code, and then have the discipline to come back and write the test and write the code and drive the code through the test to create it. That's a much better way to be able to develop this particular code, develop this particular software. So we want to be really able to do that. Well, what are some of the benefits of test-driven development? There are two benefits of test-driven development that I find to be extremely valuable. The very first benefit is the regression benefit. And the regression benefit says, I'm going to tell you the code that worked yesterday is working today, and the other benefit you get out of this is the design benefit. So when we come back from the break, I'll talk about these two benefits. We'll talk about some challenges of TDD, and of course, we'll also take a little problem and work through it as well. So why don't we take a break and continue right after that.